In this video, we're going to talk about how to deal with parameters in Python. Now, one thing that I find myself doing all the time is using point stops to add noise to whatever it is that's coming into their input. So in this case, I just have a simple sphere. It's a polygon. I increase the frequency a little bit so that if I turn it to wireframe mode, you can see, so that there's enough detail to see what's going on. Here's an attribute create SOP, which I'm going to be using later for demonstration purposes, but basically it just creates this new position attribute, and all it does, all the points have the same position except that the x component is increased by 1. So it should, if we were to use this new position attribute, position x, it should just bump it over by 1, which is what it does. And then y and z are both the same as they were before. So if we change this to new position y and z, it wouldn't change anything. So let's set this back to $tx. Okay, since we're going to need a shelf tool to contain our demonstrations, we'll just go up here to our Python class shelf and right click and say new tool. And then we'll just call it noise point. And the label will be noise point. And then if we hit apply, we have our noise point. Okay, so if we go to the script tab, script language is set to Python, so we're good to go. I'm just going to put this up here and resize it a bit so that we can see kind of what's going on. So the first thing that we need to be able to do is we need to be able to get an object that points to the parameter that we want to deal with. And there are a couple of different ways that we can do this. The first and simplest way that we can do it is by starting from a node instance. So let's just go ahead and loop over all the selected nodes. So we say for who node in who.selected nodes and tab. So now it's going to loop over every node that we have selected, and who node is set to an object that points to whatever the current node is that we're looping over. So it'll be one of the nodes that we have selected. Okay, so now it's time to get a parameter object. And how do we get parameter objects? Well, we do it with the parm function, which is a function on who.node. So who.node is a who.node object. So what we can do is we can say who.node.parm. And then this is a function that returns an object that points to a parameter on a node in Houdini. So if I wanted to grab this group parameter, for example, well, we can see that this parameter is called group, so in quotes, we just say group. So basically you're just giving it, in quotes, the name of whatever parameter you want to grab. Now this function is going to return a parameter object, so you're actually going to want to store that into a variable. So if we say group parm equals, and now if we want to say print group parm, and say apply, select our point demo node, and click noise point, you can see it say who.parm, which is the object type that points to parameters, group, which is the name of the parameter which we set there, in /obj go1 point demo, which is in fact the path to this node here. So this allows us to control any parameter in Houdini in some very interesting ways. Now the simplest thing that we can do with this object is we can simply set its value. So if we say, go ahead and delete this print statement, and then we say group parm dot, and then we can just say set, and that allows us to set the value of the parameter. Now group is a string parameter, so we could say something like blorg, and hit apply. Let's go ahead and clear this, select point demo, and click on noise point. and you can see that it sets it to Blorg. And it puts a warning on here because Blorg is not actually a valid group name in this geometry, but it doesn't matter because we're just messing around. So the cool thing about this is that if I have, let's go ahead and clear the group field here, and let's just copy and paste point demo a bunch of times. So now we have a whole bunch of point SOPs. Now if we want all of the group fields to be set to the same thing, Blorg in this case, we can just select all of them, hit our tool, and now suddenly all of the group fields are set to Blorg. Alright, this is a mess. Let's just go ahead and delete all of them except for our original point demo node. Zoom in a bit, and go ahead and display that guy again. So setting a bunch of group fields to some group name is actually not that useful. Something that might be more useful is to clear this parameter. So let's go ahead and do that. So all we have to do that is where it says set Blorg, we just remove the Blorg. So now it's setting it to nothing. So if we hit apply, select point demo, and click noise point, it clears that group field. So already you can see that this is very powerful. We can use patterns to set similarly named parameters on a whole bunch of different nodes all at once. So if we have a whole bunch of different nodes of the same type, we can control them very powerfully with Python. So now let's try setting an expression on this group field. So the way we do that is we use, instead of the set command, we actually use the set expression function. And then by default, it'll set it to an HScript expression, and since we haven't covered Python expressions yet, we'll just let it do that. So if we want to have, say, an expression like CHS, what's this parameter named? Attribute to match. So we'll just use that one. Attribute to match. Okay. Then we hit apply. Now if we select point demo, hit noise point, you can see that it's created this expression here. Now it's kind of hard to see the difference in the color, but it's actually created a keyframe here to make an expression. And the way that we can check on that is if we right click, we say expression, and say edit expression, it'll show us this expression in here. Now if I just right click and say delete channels, say we used the normal method of a backtick, so we said CHS attribute to match backtick, middle click, now it's got the ID. You notice that if I right click on this group and go to expression, it says edit string here instead of edit expression. And it gives me this. So let's just go ahead and clear this. Select point demo and click noise point again, and that puts this expression back in here. Now, it's kind of interesting now that this expression is here. You'll notice if we just comment this line out for now, and then we say group parm.set, and then say we try to set it back to Blorg. Watch what happens. If we click on this and we say noise point. Now it set it to Blorg, but you'll notice that it set attribute to match to Blorg. And if we change this back to ID, we hit apply, select point demo, and click on this, it sets it back to ID. So basically what set will do is if there's a channel reference on this parameter, it will follow the channel references to a parameter that it can set. If it doesn't hit a parameter that it can set, it'll just raise an exception. So the way that we can get around this is we can call this function, delete all keyframes. open close parenthesis, and hit apply. And what that's going to do is it's going to delete this expression here, and then that'll leave this field open and we can go ahead and set it. So then we can say group parm.set blorg and hit apply. Now why is this expression called delete all keyframes when all we want to do is remove an expression? That's because expressions in Houdini are keyframes. All expressions in Houdini are keyframes. So if we hit apply, select point demo, and click noise point. Now it sets it to blorg. There's no expression on here if I click on and off. And notice the attribute to match is still set to ID. So what if I just want to get the current value of the parameter? Say this parameter has something like slash c colon backslash blorg slash font or backslash font backslash zorg dot hipnc. So say it has something like this in here, and all we want to do is replace the font with something else. So how do we get this parameter value to begin with? Well, we can use the eval function. So if we go here in between our comment and our delete all keyframes line, we can say current value equal group parm.eval. So this eval function simply returns whatever the parameter is currently set to. So if there's an expression, it evaluates it and returns the value. And then what we can do is say new value equal current value dot replace font with something else, torque. And then we go down here to our set and we say, instead of the quotes, we just say new value. So essentially we want to say set group parm to whatever the value of the variable new value is. And we set that variable up here to whatever current value is, replacing font with torque. And then current value was set to whatever group parm evaluated to. Now if we hit apply, and we select point demo, and click on noise point, it changes font to torque. So you can already see how this could be really useful if you have a whole bunch of nodes in Houdini, say MantraRops or Geometry ROPs, that have output paths, and you just need to change one value in each one. Now you can do that really easily. In fact, we could copy and paste our point demos again, grab all of them, and then just swap these two, so it's replacing torque with font. So torque is first now, and font is second. We hit apply. Make sure that we have all the point stops selected. Now when we hit noise point, you can see that it replaces torque with font. And if we select each one, you can see that they're all set to font now. Alright, let's go ahead and delete our extra point demos and go back to our original one. So now we know everything that we need to know to make our noise point tool. So if we just go ahead and clear this field, the group field, and let's also just comment out each of these. Let's take a look at how we would approach making this tool. And even can comment out the first line. So we're starting almost from scratch. All we have left is this for line here. So what are the steps involved in creating this tool? Well, first we need to get the position parameter. Because basically what we're going to want to do is just add noise plus noise $tx, $ty, $tz in each of these fields. And it does this kind of funky thing because all the noise functions are evaluating to the same thing. So we're going to want to have a different seed for each one. So in the y, we can just say plus 1, maybe 10,000. And then in z, we can say maybe y is minus 10,000, just to get a different position. And there, that's what I'm after. Okay, so there are two things that we need to do. First, we need to be able to add noise in here. And then second, we need to be able to have a different seed for each parameter. So the first thing we need to do is we need to let's just start by setting one of these parameters. So if I just right click here, it's not gonna let me do it. So let's just go ahead and delete all the noise functions. Okay. So how do we get this x component of the position? We say x pos equals, and then we say who node.parm tx. How do we know that this is tx? We hover over the parameter, wait for the tooltip to come up, and there it is, tx, ty, tz. Now if the tooltip isn't coming up, or if you have tooltips disabled, you can just click on this gear, go to edit parameter interface, and then find the parameter in here. So here it is. And you can see that it's called t, and it's a float vector 3. So that means it's going to be tx, ty, tz. So if we cancel that. Alright, so now we have the xpos parameter, and then we need to do something with it. So what we're going to be doing is we're going to be completely replacing it. So we don't need to really get the value of it, we can replace it completely. So let's just start by deleting the current expression in there. So if we say xpos.delete all keyframes, so that'll clear the expression in this field and allow us to just set it. Now we need to put a new expression in there. So if you remember, xpos dot, the function to put a new expression in there is set, not just set, but set expression. And that lets us put a new expression in. And the expression that we want is, in quotes, $tx plus noise, $tx, $ty, $tz, close parenthesis, close quotes, close parenthesis. And then I'm just checking to make sure that this one gets highlighted as a sanity check to make sure that I have all of my parentheses in the right place. Alright, so let's see what this does. If we hit apply, and then we select our point demo node, and we hit noise point, there we go. So now what we can do is we can just copy, Control C, press enter twice, tab, Control V, you can just call this ypos, change this to $ty, and then change this to $ty. So you need to change 1, 2, 3, 4, 5. Okay, and since this is the y component, we want to just go ahead and add to the y position. So we'll say plus 10,000, let's say. And then we'll just go ahead and press enter twice, tab out, Control V, replace x with z, replace tx with tz, $tx with $tz, and then noise, it's going to be adding noise. Since this is the z component, we want to go ahead and just subtract 10,000. That's the simplest way to get a different position in the noise field. Alright, so if we hit apply, and we select our point demo, let's see what it does now. So let's just go ahead and select the node, and click on noise point, and we can see that it sets all 3 channels. So you might be thinking this is a bit cumbersome, and what if I have a whole bunch of channels that I need to set, and I want to set all of them, and just want to loop over them? I don't want to have to copy and paste all of my code for every single parameter, right? Well, yes, that's completely true. So there's another type of object that Houdini gives us that allows us to deal with sets of parameters like this very easily. You'll notice that this is really all one parameter. It's just 3 components of the same parameter. So it'd be nice if we could just deal with this parameter sort of as a whole. And the way that we do that, if we just go ahead and delete all of this stuff, is with a parm tuple. So if I say position tuple equal, so what we can do is we can say who node.parm tuple, and in this case I just give it t. Why is it t? Because if we look at the parameter name is actually t. So that's where we see that. So now position tuple is this entire parameter. And parm tuples actually have a lot of the same functions on them that regular parms do. So I can say print position tuple.eval, for example, hit apply, select point demo, hit noise point. It's not coming up because my console isn't displayed. There we go. Right now it's 0, 0, 0, but if I were to, for example, Control-Shift-Click on position, set it to 0, 1, 2 maybe, so 0, 1, 2, and then try it again. Now you can see that it's printing 0, 1, 2. So if we hit clear on that, and let's just return this to $tx, $ty, $tz, so that our sphere appears again. That's what we get. So why were we getting 0, 0, 0 earlier? Well, that's because this parameter is used internally by the point sop while it's looping over all the points. So it can't really get values out of this. And if you click on this position, you can see that it gives us 0, 0, 0 by default. So it's something that we're kind of used to seeing. But the important point here is that we can deal with this parm tuple as far as setting expressions is concerned in the same way that we can deal with parameters, with one important exception. We can loop over parm tuples and get the index that we're looping over. How do we do that? Well, we can do it with the enumerate expression. Now, if you aren't familiar with the enumerate expression, here's how it works. Basically, what you do is you say for index, comma, and then let's say parm in enumerate position tuple. And so if you aren't familiar with the enumerate expression, this is a Python expression. It has nothing to do with Houdini. Basically what it's going to do is it's going to return both position tuple, and then for each value in position tuple, it's going to return the current loop number. So if we just go ahead and print index and parm and hit apply, and then we select point demo and click on noise point. So there's our index. So for the first iteration of the loop, this is index 0. So index is set to 0. And this is our parm. So there's parm. For the second iteration of our loop, you can see it's got ty there, and index is set to 1. And then for the third iteration of the loop, you can see that our parm is tz, and our index is 2. So this gives us an easy way to get a number that corresponds to the loop number, essentially. So we go ahead and hit clear here on the Houdini console. Now we have, as we are looping, we have each parameter, which represents each component of the position. And we have a number that we can use to add to our expression. So that means that we can say parm.delete all keyframes. Don't forget that step because there's already expressions on here, so we want to delete all of them first. And then we can say parm.setExpression. Okay, so this is a bit odd. How do we know what to set it to? We need to have $tx, $ty, $tz in there. A couple of different ways that we could approach this. One simple way that we could approach it is just to use the name of the parameter and capitalize it. You'll notice that it just so happens that the name of the parameter is the same as the variable name for accessing the value of the parameter. But that's a bit unreliable because most of the time those two won't actually line up. So in this case, I think the best way to approach this problem is to just create a list. And the list will be in order of whatever expression we want set there. So what we can do is just say default positions equal, and then we can give it a string, so $tx, $ty, $tz. So this will be a list, and then we'll be accessing this list as we go through our loop. So say we delete all keyframes on this position parameter, and we just say parm.setExpression default positions index. So what this is going to do is each iteration of the loop, it'll use the iteration number in the loop to look up the corresponding default position. So at iteration 0, it'll get $tx. For iteration 1, it'll get $ty. For iteration 2, it'll get $tz. So basically, we have a list up here that we can use to set those expressions. So if we hit apply, and select our point demo and hit noise point, let's see what it does. There we go. It sets them back to $tx, $ty, $tz. So now, how do we add to that expression? Again, there are a couple of different ways to do it. The simplest way to do it is to just use string concatenation in Python. So we can say default positions plus, and then some expression. Now this is going to get a bit confusing, so let's just go back to the beginning here and comment out this line. And we'll use print statements to know exactly what we're doing before we run this. And then we'll uncomment this line and add our expression in there. So basically I'm going to print out the statement, the expression, as we make changes to it. So the first thing that we're going to do is print default positions index. We hit apply, and then we click noise point. Syntax error. Okay, so this is as good a time as any to talk about this. This is an annoying bug in Houdini. There are a lot of fields in Houdini which take Python expressions. This is one of them. And a bug in Houdini is that if the last line is a comment, it'll actually give you a syntax error, even though there's no syntax error. Now, this is really annoying, but we don't actually want to delete this line. So the way that we can get around this is just by going down to the next line and putting pass, which essentially means that there is a valid Python statement here that's not a comment. And that's all Houdini Python needs. Regular Python doesn't care, but Houdini Python for some reason does. So now if we hit apply and click noise point, our syntax error is gone, and we see $tx, dy, tz. Now notice that it cleared all of these, and that's because I forgot to comment out this line too. So let's comment out the delete all keyframes line, and hit apply. And then we'll just put $tx, $ty, $tz back in here. Okay. So now if we hit apply, we hit clear on the console, select our point demo, click noise point. For each iteration of the loop, it's printing out the expression that it's going to put in the corresponding component. So it'll put $tx here, $ty here, and $tz here. Okay, so let's just say plus, and then we'll say plus noise. We'll just leave it like that. So you're going to have two plus signs, one of which is outside the quotes. So essentially we're going to append a string, which happens to contain an expression inside of it, to this string, which happens to also contain an expression. So if this looks confusing syntactically, this is why we're using print statements to see what we're doing. So if we hit clear, and we click on noise point, this is what this is actually going to evaluate to for each component. So it'll be $tx plus noise, $ty plus noise, $tz plus noise. Alright, so now we just want to give it our full noise expression, so $txyz. Hit apply, let's go ahead and clear the console. Click on noise point again. And now we can see that our $txyz parts of the noise expression are included. And now comes the fun part. We want the y component of the noise to have some number added to it that's very large, and it needs to be different for each component. Now again, there are a couple of different ways that you might approach this, but I think the easiest one, for now, we're going to just add two single quotes there. So you can see there's two single quotes. And then in between, we're just going to say plus index plus or times 10,000, and then a plus. I'll just go ahead and get rid of some of these spaces, so there's only one space in between each one. There's actually a couple of problems with this, which we'll go over in a moment. The first one is going to cause a syntax error. If I hit apply and hit clear, click on noise point, or not a syntax error, I guess. It says it cannot concatenate str and int objects. So if we hit OK, what it's complaining about is this index times 10,000 is an integer, and we're trying to add strings together. So it's getting confused because this is an integer, and it doesn't like that. So the way we fix that is we can just say that this is str in parentheses, and there we go. And that'll fix the error. If we hit apply, make sure the point demo is selected and hit noise point. Now it prints something, but this is the wrong expression. That's $ty0, $ty10,000, $ty20,000. It's almost right, it's just missing the additions. And that's because in our string right here, it's not actually, like that plus sign is not in the string. So we can just add it here. $ty plus, and then we get our extra space here just to make sure that it looks nice once it gets put into the parameter. Because if we're creating an automated setup that does it, we might as well make it look pretty. Alright, so if we hit apply, and let's go ahead and clear the console, and then click on noise point, there's the expression that we want. So if at this point you're not getting these expressions, you'll need to back up and go through that whole part all over again. Or if you want to, you can pause the video here and just compare your expression with mine and make sure that you have all the same stuff in here. Okay, so instead of printing this, let's just go ahead and dump it into a variable. So let's say new expression equals. So new expression at each step is just going to be set to whatever this equals at that step. So let's go ahead and uncomment out these lines. So now it'll call delete all keyframes again. And then it'll create this expression, which we already saw what that will make. And then it'll set that expression to the current component of the parm tuple. So now instead of default positions index here, we can just delete that whole thing so that we end up with parm.setExpression with open close parentheses. And then inside the parentheses, we can just type new expression. And now we can just go ahead and get rid of this pass statement because we don't need it anymore. Now if you do get rid of the pass statement, make sure you get rid of this new line here. Because if you don't do that, then you'll get that syntax error again, or you might. So make sure you get rid of that so that if you hit the down arrow, you can't go down past this line here. So if we hit apply now and we clear the console, make sure we have point demo selected and click on noise point. There it is. If I close the console and hit accept here, you can see I have my nice noisy sphere. So now just for fun, let's one last time, we'll drop down a fresh point swap and plug it in. So this one doesn't do anything to the positions yet. We select that guy, Control C, paste him a whole bunch of times. So we have 7 of them now. Now we could just select all of them and say noise point. And now all of them have these awesome expressions on them.